Hello surveying students, this is John Hannon. I wanted to make a video to supplement a little bit the Chapter 5 content on differential leveling. It talks about several different leveling types of differential leveling even. I want us to be sure we get the basics down because it's pretty important. And again, I'm in Chapter 5. I've made some screenshot images so I can kind of point around on the images. It's a little bit blurry, but obviously you can get a clearer image in your text, whether it's paper or the Kindle version. I did it so I could use my pointer. So if I come in here and kind of make this blue, I get a little pointer. And differential leveling, I'm just going to go over some things that solidify it in my mind. Maybe it will help you also, as well as setting up the calculations and the notes in a spreadsheet, which I think will help you when you do the exercises. So, the basic premise is that we're reading a rod. We'll talk about that in just a minute. You have to be able to read the rod through the telescope, and I'm going to keep that simple at first. We may go farther in the lab. But for just the general theory section, differential leveling is trying to find the differences between elevations of points that are spread apart. And so we have to do these turning points and different instrument setups. Now what helps me in my mind, remember a turning point is where the rod is, okay? So that helps me figure out what's going on. Turning point is where the rod person is, not the setup. And I really like the way the text, this portion of the chapter is the best explanation, the most simple and logical diagrams that I've seen across several surveying texts. But remember, the turning point is a rod location, not an instrument location. Those are the setup points. And these can have many different turning points. They don't go in a straight line necessarily. Mostly they don't. And they're on different elevations of ground. You can see that if I look through the telescope here, I'd probably miss the rod over here. That's why we have to do a setup to and do a backside on the turning point. Okay, so the main thing is you find a benchmark which should have a given elevation. Now the book discusses that you can do this without a known benchmark, and that's true. I want you to know that. But this is just the traditional differential survey loop speech and lecture. Let's assume we're setting up on benchmark A. There's a person holding this, probably a Philadelphia rod, or maybe a nice fiberglass one. And we're going to deal right now just in ones that use tenths and hundredths of a foot. And so the instrument person does what's called a backsight and reads the rod. Obviously, writing down in the notes, in the field survey notes, 1.55, because that's what's read on the rod. Now, a turning point, roughly equidistant. So, in theory, the book emphasizes that these two distances be roughly relatively equal. The person with the rod goes to this point, holds it vertical, and the instrument is turned around, and the telescope reads this rod reading. and records that number. In this case, it's 6.75. After that's done, the rod person stays on the turning point, and the instrument person does another setup, anticipating where the foresight's going to be, hopefully keeping an equidistance between the two. And at that point, once the instrument is set up in the second location, takes a back sight on the rod at the turning point where that rod person stayed and records 1.25 in the field book. At that point, the rod person moves to another location. They're calling this Station C. The instrument person rotates the telescope around, reads this reading, which is 6.50, records that in the field book, and this elevation is computed. And the book does a very good job, in my opinion, of showing you the steps for the field notes, as well as these diagrams. Here they're showing the math calculations, okay, just straight up. This is not what the field book would show. The field book shows it a different way. And I think that's a quite good method. Let me scroll down to my other screenshot. I encourage you to find this diagram, figure 5.4, in your book, and follow. It's a little bit blurry in this screenshot from my Kindle, but this has a 1, a 2, a 3, a 4, a 5, a 6, and a 7. And that shows you how to set up a spreadsheet that I would like for you to set up. That way you can do the practice problems. The even number ones the answers are in Appendix F, I believe, and I will give you some problems. Probably could be some of the odd numbered problems. If you have this set up in a spreadsheet, you'll be ready to roll. But this is nice. This is a nice diagram. It shows you the sequence of how the numbers are entered. This is the field book form, and you can do the math along with it, as well as the arithmetic check. And I'll go over that. Maybe I'll do it in a separate video just for time. Okay. And it's important how this is set up. These columns the order is important. I've seen it flipped, but it starts with the station, which either shows a station number, a benchmark, or the turning points. And remember, this is about elevation, or the Z coordinate, not X and Y. And the back sights are a positive number. Typically they're added, and the foresights are subtracted from information in the field notes. And there are some formulas in the text that you should definitely memorize. So HI equals elevation plus backsight. That's the way I would think of it. HI equals ELVK for known plus BS. And here they kind of have it like this. That's an easy way to remember it. And then new elevations are simply the height of instrument minus the foresight. Okay. So just remember that backsights are plus, foresights are negative. And then I'll also show you when I do the spreadsheet how I'd like you, or a nice way to do the arithmetic check. That's where you sum all the backsights, you sum all the foresights, You subtract the back sides from the foresides, add that number to the elevation, and you should get the ending elevation or close to it. So here 335.15, and you can see that 345.6 plus the backside summary minus the foresight summary equals the same number, and that's a nice check. Looks like things are pretty good in that instance. Maybe the last thing folks may struggle with, that is reading these rods. And for right now, or initially, I'm going to stick with the decimal portions of the foot, the rods that work that way. Okay. The text goes into a description of how to read the rod. Maybe I can help a little bit with that. Some of it was even confusing to me, especially when I got to the metric one and so forth. So if you're looking at a rod like this one that says figure 5-12, the feet are the big numbers. Now this is a color, but this 4 would be red, in red. The rest is in black. So if you're looking through the telescope and your horizontal crosshair hits somewhere in here, you know that below the 4 is 3 feet something and above the 4 is 4 foot something. Okay. The large black 7, 8, and 9 are the tenths of a foot. So obviously this crosshair is below the 4, therefore we have the 3. Let me get my blue going here so my pointer works. So we've got the 3, right, because it's below 4. We're above 8, so that's 8 tenths. And this is what you should definitely get. Notice the shape of these little bars. Okay, the one with the 8 that comes out a long way and is beveled in this direction, that's a 0. And then this point is 1, this point is 2 on top of the bar, 3, 4, 5 is the short beveled one, so I know that's a 5. And if you did this a lot, you wouldn't have to do the count that I'm going through, because you would just recognize that's 5. On top is 6, 7, 8, 9, and 0 again is the top of the bevel. All right. So we've got 3 foot, 8 tenths, and then 0, 1, 2, 3. And that's fine, taking it for now. You can take it to 2 decimal places. This one's not quite on the top to make it 4, and so they've interpolated for that 7. That's fine. Do it that way. I would probably go 0, 1, 2, 3. For our purposes, and I'm not a professional surveyor, I would call that 3.84. Probably breaking all the rules from the first chapters there. I just want you to not be afraid of reading the rod in this format, decimal formats of a foot. There are all kinds of different rods. The metric ones, there's also ones that are fractions, there's ones that are read from the top. Just want us to get the basics down here, okay? Reading the rod. So I hope that's helpful. I'll do another video on how to set up the field notes in a spreadsheet. And it's pretty neat stuff. It's simple once you understand the concept, all right? It's not hard math. You have to visualize what's happening with these diagrams. And again, this one is very helpful in my opinion. on the order of how you record field notes, what you subtract from what you add to what, and of course you can program that with a spreadsheet, but it's still important that you could do it freely if you had to. So again, I hope this is helpful. Thank you very much.